So today we're going to talk about misconceptions on nuclear weapons and nuclear warfare. Been watching a lot of videos from Full Spectrum Survival, Canadian Prepper, City Prepper, Urban Prepper, a whole bunch of them, and also all the news. There's a lot of misconceptions on what's out there, how things work. So the first thing I want to talk about is there's a lot of misconceptions that a nuclear weapon of 1 megaton compared to a nuclear weapon of 20 megatons, that the 20 megaton weapon has 20 times the effects. While it is true that a 20 megaton weapon would have 20 times the energy, it's not a fact that the effect would be 20 times the effect of a 1 megaton weapon. The reason for this is this formula. This is the volume of a sphere. V equals volume, and the important thing is the radius, which you see here is r cubed. So with that r cubed, you're multiplying r times itself 3 times. That is the determining factor of how the effects of a nuclear weapon are distributed in a sphere. So if you look below that, you can see the radius in a circle. That's a two-dimensional representation of a three-dimensional sphere. So if you take a balloon or you take a globe of the earth and you look at that, that's a sphere. So what happens is a 20 megaton nuclear weapon, the effects would be distributed over the radius. And when you compare that to a 1 megaton weapon, the radius is not 20 times bigger. This is why if you look at actual charts of nuclear effects for various weapons, you'll notice that there is not a direct parallel with the size of the weapon and the size of the effects. The next misconception is how radiation decays following the detonation of a nuclear weapon. Now, nuclear weapons, if they're unsalted, which means they're conventional nuclear weapons, follow the rule of 7 for the decay of fallout. So when you're looking at the rule of 7, it cannot be a cobalt-cased nuclear weapon, it cannot be a nuclear power plant, and it can't be a nuclear weapon detonated at a power plant. The reason is the concentration and distribution of radioisotopes are different for those type of explosions than you have with a conventional nuclear weapon. Now, a conventional nuclear weapon is a fission, boosted fission, or a thermonuclear weapon, which has a fusion component to it. So these type of weapons, the decay of fallout at your position will follow the rule of 7. Now, what's important to know here is the decay period is at the 0 point for your location. So if one nuclear weapon is detonated, it may take 10 hours for the radiation fallout to reach your position. So the rule of 7 begins when you hit peak radiation. So you would use your detection equipment to follow the increasing radiation till it reached a peak. If there are multiple nuclear weapon detonations, it may take several days for the peak radiation to be achieved because the fallout has to get to your location. Once your detection instruments tell you that you've reached peak radiation, that would be your 0 point. So from that 0 point of peak radiation, after 7 hours, the radiation magnitude would have dropped to 10% of what it was at the 0 point. So the next 7-fold increase in time would be 7 hours times 7, which would be 49 hours. At that point, the peak radiation would have dropped to 1%. Now this keeps going on to infinity. So over time, your radiation will continue to drop down. The next point of confusion in a nuclear war survival scenario is how to measure radiation. All of the military charts, all of the civilian charts are designed for the instrument to be 3 foot off of the ground. So when you're looking at charts for radiation safety, as well as lethal doses and doses that produce radiation illness of varying degrees, they are all measured by an individual standing up with the survey meter 3 feet off the ground. Now, what happens is the bulk of the radiation is laying on the ground. That's where the fallout is, right? So if you're standing up, your whole body radiation dose is going to be less than if you're laying on the ground. So let's say you're laying on the ground, taking cover, or you think the radiation levels have dropped low enough from a 3 foot measurement that you go outside and you sleep on the ground, or you lay on the ground to do work, and your body is an average of 6 inches above the ground. You're basically in direct contact and very close to the radiation. So your whole body dose may be lethal, even though your instrument says at a 3 foot height measurement, it's okay. So you really need to listen to people that know what they're talking about when it comes to radiation measurement, when you can leave your shelter, so on and so forth. The biggest myth of them all is that nuclear weapons will be used only on their own, and that mutually assured destruction is something that everybody believes in. And I'll tell you first off, most military people, strategists, and many other armies do not believe in mutually assured destruction. With certain attack techniques, certain use of weapons, one side can win. The question is whether that's going to be a Pyrrhic victory. And that all depends on the mental mindset of the leaders, not the warriors. In Russian doctrine, Chinese doctrine, and US doctrine, there's no separation between NBC. So NBC is nuclear, chemical, and biological. Then you have conventional weaponry, and then you have space weapons. And space weapons are composed of energy weapons and also mass drivers, which are kinetic weapons. So when you look at this chart, what you will find out is in the Third World War, in an actual nuclear war, all of these items will be in use. The Russian military doctrine, as well as the Chinese, indicates that the most efficient yet economical weapon will be used against appropriate targets. So in a nuclear war, you could have nuclear strikes, biological, chemical strikes, and long-range conventional strikes against targets, depending on which one actually destroys the target or disables it properly and at least effort. Now, space weapons are something that's not discussed much in public. Now, an example I'll give you is way back in the 80s, the late 80s, they sent a proposal to all the Ivy League schools and said, hey, if an alien race was at war with the Earth, how would we attack their planet? So, of course, all the think tank fools came up with all these hugely expensive and unreliable methods to fight an interstellar war. The actual solution to that problem was you take a very basic spacecraft with arms on it, with minimal computers, where it's mostly mechanical, and all you do is grab asteroids near the area and put them in low orbit. So you would use a mass driver bombardment against the alien planet. So that's an example of how some people think versus how intellectuals think. Usually they over analyze the problem and make it hugely expensive. So what you got to keep in mind is if World War III starts, all of this stuff will be happening simultaneous. There's no threshold. It all occurs together. So please share your thoughts. If you have any other questions or comments, please leave them. We can carry on this discussion in the future if you want. See you on the next video.